Okay, so notice that arc sine, there's this a value. Now this time we do have to be concerned with that because a squared is 25. That means a is 5. But notice the difference between arc sine and arc tan. Arc sine, you just have the a underneath inside the arc sine. But for arc tan, a is on the inside and a is on the outside, and a is always in the denominator in this case. So just be careful about that. That's what I kind of had to check on. And it looks like that means my answer is going to be this one right here. The something squared is all of x plus 2, so that's u in this case, and it's being divided by that value of a, which in this integral is squared, but here it is no longer. All right, up next we've got another u substitution question. Again, the idea is I see a function that if I were to derive it, would give me another function that I also see in the equation. So what am I talking about? I'm talking about this x cubed plus 4. Now one big reason to start thinking u substitution is the fact that there is no like quotient rule or rule for division with integrals. You either need to do u substitution or notice that there actually is some polynomial or synthetic division you can do, or maybe this is some kind of other problem. But the idea is, if this is u and I derive u, I would get 3x squared, which is a form of, it just has a different coefficient, what I have in the numerator. The idea is in the numerator there is no 3, so just divide the 3. There. Now I have exactly what I have in the function. I see x cubed plus 4 in one part of the function, and I see x squared dx in the other part of the function, so I can replace them with what I have right here. I have a 1/3 du, it's technically all in the numerator, but the 1/3 is still going to kind of pop out front, over just u. And we've seen du over u before, that's classic ln, absolute value of u plus c. This time we want to actually plug back in what u is. We want to turn this back into an x function, and so the correct answer is D. 5 more. Now I need to do a right Riemann sum with 4 equal subintervals. And the key to this problem is you just need to see what's going on here. That means I have got 0 being carried for half of a value. If you kind of notice, if you want to split this into 4 pieces, you have to count by halves. So 0 times a half is 0. And then now I need to take this value, 5, and carry that for a half. So overall that's going to be 2.5. Plus 3 carried for a half value. So that's going to be 1.5. When I say carried, that really means we multiply it. And then 5 again times a half, another 2.5. So we've got 6.5. All right, once again, we've got a fundamental theorem of calculus idea going on here. It's saying if you notice what big F is, and you notice that little f is the derivative of big F, then what happens when you integrate little f from -5 to 5? Well, if you integrate little f in general, if you integrate little f, then you go back to big F by definition. And we're doing a definite integral, so it's big F of the top value minus big F of the small value. And so let's actually figure out what that is. If we plug 5 in, that would be 0, minus if we plug -5 in, that would actually be 40. It would be -40 inside the absolute value. It would absolute value to +40, but there's still a negative out front, so our overall answer is -40. 3 more. So speaking of no quotient rule in synthetic, or I mean in integration, but possibly needing synthetic division, here's that question. Would this be on your FRQ this year? What I'm going to say is, gosh, I hope not. Notice here that I have to fill out my zeros for the missing powers, so this is going to take a long time. I'm going to go through this pretty quick. I'm hoping this is not what you see on your AP exam, but who knows. All right, the question is, how do you make x cubed look like x to the 6th? You need to multiply it by x cubed. Now distribute that to both parts. 3x cubed. Make sure you put it underneath its like term. Then we subtract, which means change the sign. And now I have 0. Bring that down. Well, that's still 0. Bring the next relevant thing down. And I'm actually not even going to, well, I guess I could bring everything down. Why not? But I'm only going to bring down the actual like values of the function. I'm not going to bring down, well, whatever. I guess I will. Anyways, so now we're here. How do I turn x cubed into 2x to the 4th? Well, I need to multiply 2 and multiply an x. And so now I have a match, 2x to the 4th, but I also get a 6x. And again, subtract, change the sign of this, change the sign of this. Now those cancel, and I'm left with negative 3x cubed minus 9. And now the question is, how do I make x cubed into negative 3x cubed? And I need to multiply that by negative 3. When I do that, again, I get a match. Now I get negative 9. And, ooh, this one's actually pretty special. This is not what I thought it was going to be. And then again, change the sign, change the sign. We actually have no remainder this time. So now really what we're integrating is the integral of x cubed plus 2x minus 3 dx. Make sure you put that in parentheses though. And when you integrate that, long story short, you will get this. But one thing I want to say is what you're usually going to see is this will not be 0. And if that's not 0, then you would also have to write, let's say the remainder was, I don't know, 7. You'd have to write this in the integral plus 7 divided by what you were dividing by to begin with. All right, so you'd have an extra, if your remainder was 7, you'd have 7 over x cubed plus 3, and you'd have to do some kind of integral trick with that. 2 more questions. All right, how many fans attend the swim meet? This question is just showing the rate at which fans enter the stadium. And in other words, remember that integration is an area question. So if we're looking at a rate, remember that that's like fans per hour. So in other words, the y-axis is fans divided by hours. The x-axis is hours. So if I want to find fans, if I find the area, if I multiply height times base, look at what those units are. Fans over hours times hours. Well, hours are going to cancel out, and you'll find fans. So in other words, you're looking for the area or the integral of this structure. And that's going to be, you've got a trapezoid here. So from 400 to 800, if you average that out, you'll be at 600. So we have 600 in the first hour, we have 800 in the second hour. So 600 plus 800 means that we are 600 plus 800, 1,400. Last one. And there's 2 ways of doing this problem. One, actually integrating each of these, and the second is actually looking at this and figuring out which one derives to the left. And to me, that's easier because when you look at ln, the trick about ln is, it's, again, what I said is it's the derivative divided by its original contents. So this one has the original contents dividing. This one has the original contents dividing. This one has the original contents not dividing, but let me show you what happened there. Wait a minute. Oh, sorry, it just changed the order on me. There we go. Yeah, but this one still looks a little bit special. There's something happening here. Just let me show you what happened there. When you derive that, you're going to get 60 y squared divided by 20y cubed plus 5. And then all they did was they just reduced this by 5. That would be 12, 4, and 1. And we did it. So happy.